Hello everyone, this is Levi Sheridan. Today I am making a video about an HHO generator I designed for a project in which I was attempting to create a setup to turn liquid water into hydrogen, gas, and liquid oxygen. For those of you who do not know what an HHO generator is, it is a device that uses a process called electrolysis to turn liquids, specifically in my case liquid water, into hydrogen and oxygen gas using electricity. And the way it works is there's an electrode and a cathode, and when you put a current across it and submerge these into the water, on one plate oxygen gas is generated and on the other plate hydrogen gas is generated. So here's my design. It's a modular design, meaning you can connect multiple of these together, which I'll show you later. But it's made up of three primary tubes here made out of borosilicate glass and a connecting tube at the bottom. Inside of two of the tubes are the anodes and the cathode, as I have mentioned previously, and at the top of the tubes there is an outlet for the hydrogen gas and the oxygen gas, as well as a connection point for pressure transducers to regulate and maintain pressures in the tubes. I'll show you inside. Inside you can see the anodes and cathodes are made up of concentric tubes, specifically three of them, connected at the bottom with a stainless steel connector that connects them all together into a common lead that is let outside of this bottom tube and is sealed with a rubber washer. And to this, an electrical connection can be made with a wire to run the current through these. And at the top, it also has one of these connectors, as you can see. And then there's the outlet port for the gas. Connected to the borosilicate tubes are these 3D printed plastic pieces permanently connected at the top and bottom, and they allow a connection to be made with the outlet cap here with the transducer and the outlet port, and it's sealed with a rubber O-ring around the perimeter of the tube, and these two sections are held together with four nuts and bolts. And there's a very similar setup at the bottom of each tube, except there's an intermediate part between the tube and the main connecting tube at the bottom that connect all three of the tubes together. So there's two O-rings here and 8 bolts total, but once again only 4 holding each section together. So this top section would be permanently attached to the glass and would mate with this intermediate section, which would then mate to this bottom tube. Both sides are identical, so that's the same. And in the center there is just like a water tank, kind of like a tank to kind of level off each tank here, and it's where the water is pumped into from the top. So this is a solenoid valve that can be open and closed, and there's a quick disconnect port, which I'll show you later. And basically water would come in here, fill up this bottom section, and then raise up into these tubes until the desired level is achieved. I think it would be great to implement some kind of water level sensor, probably in this section here, to ensure optimal water height. But for now, that's it. And at the bottom of this tube, there's also another solenoid with a quick disconnect valve, so we could drain this for maintenance and other purposes as well. And then there is these two parts here that allow for this whole construction to be mounted to a frame, which I will show you later. So that's pretty much just one unit of the HHO generator. Hydrogen would come out of one side, oxygen would come out of the other. And then we have the water fill port and the water outlet port, the anode and cathode connection points for the electrical aspect of the design. And then here is a set of 3 of them put together. So now you can see how I've connected the water inlets as well as the water outlets down here with a tube. And then all 3 of the hydrogen side generator and the oxygen side of the generator, all 3 of those tubes have been connected, but also separated with individual solenoids, so we can turn off or on each individual tube. If we are not using one, we can just turn it off, or if we need to regulate one of their pressures individually, we can also do that. And then there's a common outlet. Same thing for the water. If we want to turn one off, we can simply turn off the solenoid and water just won't go in there. Same deal with the bottom. We can drain specific ones if need be. And then there's a common on-off for all of the waters here, another solenoid. These 3 water inlet connections are quick disconnects, so you can take each one off individually and easily remove this. For the gas array, they all are also quick disconnect, but you have to have multiple hands, so it's actually impossible to remove with one person without a tool, which is actually a safety feature just so people couldn't remove this array while in operation very easily or by accident. Yeah, and then at the bottom it's very similar quick disconnects with the 3 solenoids. And then I'll show you the whole structure on the frame here. This is a frame I designed out of, I believe, 2020 aluminum extrusion. Maybe it's 1 inch, I don't remember. Regardless, it's a frame that could house a water tank, hydrogen tank, oxygen tank, a power source as well. It's pretty much it. I never built this, however, I did print a lot of the parts. I just never invested in the valves or the tubes or the machining of certain parts. I also bought a cryo cooler for the liquefaction of the oxygen as well as the helium compressor for that, but this is actually like a year old or 2 years old of a design. I just wanted to make a video about it because I thought it was cool, but that's it for now. Thank you for watching. I hope you have a wonderful day. Thank you and goodbye.